The Selective Laser Sintering SLS technique is used for the 3D printing of objects using powdered polymers. The process begins by dispersing a thin layer of powder onto a platform in the printing chamber. Then, the printer preheats the powder to a temperature slightly below the material's melting point. A laser increases the temperature of specific areas of the powder bed as it moves over the model, solidifying the piece. Upon completing the printing, the finished parts are removed from the printing chamber, separated, and excess powder is eliminated. After retrieving the piece, the remaining powder is filtered to recycle the larger particles. Since unfused powder degrades at high temperatures, it is recommended to use new material for future prints. In the case of SLS, primarily plastic polymers are used, especially nylon, with polyamide, PA, being one of the most common materials in this technique. Recently, the research group led by J. Angel Menéndez at INCAR-CSIC in Spain has achieved a significant breakthrough by developing the SLS technique to print porous carbon parts using a natural polymer. This innovative approach has enabled the manufacturing of porous carbon structures with unique properties and potential applications in various fields such as energy and catalysis. The use of a natural polymer instead of traditional plastic polymers opens up new possibilities in terms of sustainability and improves the environmental viability of this 3D printing technique.